Hello, today we are going to look at curve and or line of intersection, or curve and or line of interpenetration. We have a question here that reads, given is the front elevation that is incomplete, showing two cylinders, a vertical cylinder and a horizontal cylinder joining at right angle. Draw the given front, complete it, have the complete plan, and draw the development of the vertical cylinder. Now what we are going to do is, first of all, we are going to draw the given front, and then out of which we can draw our plan. Then from there we can proceed by drawing the development. So what we can do, we can first of all draw the given front. It has the dimensions given, so we can say let this one be our beginning point, and we are going to have a baseline, and this baseline here we shall draw. This is our baseline. Let's say we are starting from here. So starting from there, the vertical is 70, so we can draw 70, or the height of the vertical cylinder is 70, so we can have our height. Our diameter is 40, so we can have our 40 measured here, and here it is. Then again we draw the vertical on this other side. We are using construction lines, so should not be so much concerned, worried about the line of intersection. That one will be drawn later. So that is it. We can complete. Now that is our front elevation showing the vertical cylinder. We can include the horizontal cylinder that joins it at that 5 mm above the base. So we are going to measure that 5 from the base, and we get that point where the center line for that cylinder passes through. Here it is. Now we can draw the center line. This is our center line. Now the diameter for the intersecting cylinder is 20, so we can come and measure our 20 here. Is it really 20? It's 15, sorry for that. It is 15. So we can have our 15 here. Okay, then we can also have another 15 here. That's 15, 15. Then we can draw lines passing through it. We also do the same here. The extension is 20, so we can have our 20. Then we complete the vertical. So that is our front elevation of the vertical and horizontal cylinder. Now after we've done this, We are going to draw our plan. Our plan for a vertical cylinder is a circle, is circular. So we can first of all get to know where the midpoint is, where the center line will pass through. We all know that from here up to here it was 40, so our radius will be 20. We can have our 20. Now through that 20 we shall have our vertical center line. This is our vertical center line. Now let's say our circle is gonna be drawn anywhere on that center line, and our circle is of radius 20. So let's say we are going to draw it here. That's our circle. Then we are going to have this horizontal center line for the circle. Now, once we've done this, we are also going to project the horizontal cylinder to have its plan. So the normal projection vertically down, we get the plan. So we're gonna project this. Once you've done so, we can transfer the distances, that is to 15, 15. Transfer it here. And here. Then we can join to our circular plan. There we are. Now, what we shall do next is we are going to have a circle here, and this circle here shows the end elevation of this horizontal cylinder. The same replica of a circle will be drawn here, that the numbering somehow different. Using the center lines, we can have a circle of the same this radius from here. We draw it here. The same circle will be drawn down here, so we can still project the center lines. So again, we shall have another circle here, that center line of the same radius. Once we have this, we are going to divide the circles into 12 equal parts. So we can start by the first one. With the radius, we can make those arcs up and down. Then we join those lines. We can number as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We divide the other one again, the other circle, into 12 parts. So the same procedure will be applied here. Now, when it comes to numbering the circle below here, it will be somehow different with this one. Simply because, like, if this one is showing the end elevation of this stretch, it means this is how our circle is. So that this number 1 is this one here, and this number 7 is this one here, okay? And then this number 4 is this one here, the one above, and this number 10 is this one below. So if you do this way, okay, this 1 comes here and 7 takes back this position, and then our 10 picks the position below, and 4 picks the position above. Now let's say we want to draw the plan. The plan, it means we are going to shadow this horizontal cylinder back on the ground, on the floor. That means you're going to look at it from top. Look at it from top, it means you're going to see number 4. And therefore, if you see number 4 on this side, this is the top. You'll be able to have it this way. Okay? We're going to draw this is our plan for this horizontal cylinder. So if you want to draw its elevation, it means you tilt it this way. If you tilt it this way, this one becomes number 4. So you can write here as number 4. And then this one becomes number 1, the one below. And then this one becomes number 7, the one above. And this one here becomes number 10. You write it here. So we shall have completed that. Then we just put other numberings as 2, 3, 5, 6, 8, 9, 11, 12. So this is how we are going to do it. Next thing we shall do is we are going to have our curve of intersection, and for us to draw a curve of intersection, we're going to draw a horizontal line to come from this, and they meet lines from this other end, somewhere where they intersect. It gives us that particular curve of intersection. So let's draw those lines horizontally. The first one is this. It's 8, and we can have 8 and 4. Next we can have this. We can have this. Then the base, we can still project the base. We can have this. We can have this. We can also have this. Okay. So we can still elongate these lines. Once you have had that, we can have these other lines. Now these other lines, they will come and meet this circular plan. They will not pass through the plan, so we just bring them to meet the plan. But the first one has already joined, the second one is here. So we bring this one. We bring it to meet the plan. The next, again, we bring this to meet the plan. Next, we bring that, number 5 and 9, to meet the plan. And lastly, we bring this other one. Once they have met the plan, we can draw them vertically up to meet these other lines. Having a horizontal line there, we can project this line. So this one goes, come to the next. Lastly, there it goes. Now once you have that, we want to locate the points where our curve of intersection will pass through. The first one is number 7. We come with it, we look for where 7 is here. Okay, next is 6 and 8. So come on the same line. This is 8 and this is 6. Next is 5. So come and look for 5 and 9. Look for 5. This is 9 and this is 5. Then lastly, it's 10 and 4. So this one is 10 and 4. Come with it, 10 and 4. Then what we'll do, we'll draw a curve to join the lines, and then we complete the drawing. So this is our complete plan and a complete front elevation. What you are remained with is to complete now the development of the vertical cylinder. So we are going to project the base. So it's like we want to cut this cylinder somewhere here along that line and open it. Once it opens up or opens out, it gives us the development showing this cut where we are going to fix the horizontal cylinder. That cutout will be circular in nature. So how do we open this? It means the circumference assumes the base or the length. Then the height assumes the width. So we are going to have a rectangular shaped development here. Then we'll be able to transfer these points on our rectangle. So what we shall do first of all is to get the circumference by taking pi d, that's 22/7, multiplied by diameter, which is 40, and see how far it will go. So after calculation, you realize that the circumference is 125.68 millimeters. So we are going to measure 125.68 along this base. We can start it here. Then we measure 1 to 5. That is 12.5. I've put 0.6 because there's a round off. Now, again, we project the vertical Then we complete by joining the vertical. On this other side, we do the same. After we have drawn the development, one other thing we shall do is to transfer this point by projection. So we do the same thing as it has been. We project the lowest one. We come to the next. The next. The next. The next. We have projected those lines. Next, we are going to be carrying this distance from here to here. We transfer on this side. Now for us to do so, we first of all get to know where is our center point. So that means if this one was 12.56 or 12.6, we are going to have half of 12.6. Let's just do that simple calculation. We want to get the center point or the midpoint. So it is 6.3, or we can possibly say 63 millimeters. So let's see where 6.3 is. There it is. Then we draw that vertical line. So we are assuming this is 0.4 as from here. So we are opening it. And when we open it, it means we are going to carry 4 to 3, 4 to 5. We transfer. So the first one we shall carry is 4 to 3. And when you come here, you transfer it here. Then 4 to 5, which is 4 to 5 is equal to 4 to 3. Next is 4 to 2. So this is 3, this is 5. 4 to 2. Bring it here, mark. Next is 4 to 6. And lastly is 4 to 1. Which is also equal to 4 to 7. So this is 1, this is 7. So we shall draw vertical lines above those points. That's how we do it. So once we have drawn those lines, there are points where they are intersecting. Now we are going to be transferring those points as we mark the dots along which the circle passes through. So like we can start by number 1. Here is point 1. We look for 1. Here it is. We meet here. Next is 2. 2 is here. We come, look for 2. We make a point. It is corresponding to 12 because they are on the same straight line. So you bring it here again at 12, 11, and 3. So 3 is corresponding to 11. And it is here 3. Next is 10 and 4. 4 is corresponding to 10 and 4 here. Next is 5. 5 is here. It corresponds to 9. They are on one line. Next is 6. 6 is here. It corresponds to 8. So this is 6. Then lastly we have 7. Here it is. So those points will be connected by a line. The joints will be connected by a curve. Then we are going to complete the base because this is a development of the whole vertical. Good. Now what we have drawn is we have drawn our front showing our curve of intersection. We have drawn our plan. Here it is. And now we have also drawn development of our vertical cylinder showing the cut out circle. Thank you very much for attending to my lesson. Enjoy your day. Consider subscribing.